Hi there, this episode is an audio rip of a YouTube video. If there are any references to the screen or to the video itself, then be sure to go over to YouTube and actually check out the video, which will be the same title as this podcast. Thanks. And here we have another relatively short outcome 5 in the 2396 course. This is understanding the factors that affect the choice of sources of environmental technology. This one, again, it's not in the written exam. This is a question that will be part of the assignment, the big project, and it's a consideration. It's just assessing your understanding on the presence of environmental technologies and when we should consider them, shouldn't consider them, what benefits there are with one or the other. As you can see, it's one little question within that project. The key thing really is to determine if the design that you're being offered to do has a suggestive benefit with environmental technologies. I mean, if for example, it says in the scenario, oh, it's very windy all the time here, or oh, we're right next to this stream of water, this body of water, which we can have. If there's a clue that there's a need to consider environmental technologies, or oh, we have these huge acres of ground, what could we put on those that will benefit? Have a little think about what benefit, what restrictions there are to some and what benefits there are to others. Okay. But this is broken down in 3 little areas. So state the factors that will determine the suitability of an alternative energy source. So, for something to be suitable, there has to be let's say solar. Is solar suitable if the rooftop of the building is constantly in shade? Clearly not. So those are the kind of things that we're looking for. State the components used in environmental technologies which form part of the electrical separation. So this is just a bit of this is just saying, okay, so you're going to do a PV. What are components of the PV? Okay, well we're going to have the panels. We're going to create the array. And we're going to have the inverter. And then you're going to have CHP. Oh, we're going to have a generator somewhere. We're going to put that thing. So just understand that utilizing these environmental technologies will require stuff, and stuff has to go somewhere. All right, the third one, state the factors that contribute to reduced energy consumptions in a building. Now, bear in mind, this is from an electrical perspective or an electrical design perspective, because you could easily say, oh, thermal barriers and thermal insulation and reinforce all this stuff to keep the energy. That's true, but what we're kind of thinking of here is the electrical perspective. How can electrical installations benefit or help reduce energy consumption in a building? So we're looking at management systems and things like that, really, there. Okay, 5.1, state the factors that determine the suitability of an alternative energy source. Photovoltaic, how much solar radiation is available? I don't know how much you know about it, but obviously up in the northern hemisphere, we ideally would want some kind of south-facing angle due to the fact that the sun rises and sets at that angle. We need to try and have that orientation as best we can. Have you got the space? Is it just on the roof? How much, there are calculations we can do to quantify how much area can achieve how much power. Is this a standby supply, a backup supply, a temporary supply? It depends on the circumstance, but you may need a large area if you're going to achieve enough PV supply to actually have a standby source of energy. Wind turbines, amount of wind speed, regularity. If you're near the shore or the coastline, probably quite often you'll have a lot of constant wind speed, or a valley. But if you're just on a bit of flat land that gets wind days now and then, you've got to consider efficiency with that. With combined heat and power, this is obviously something that's getting more and more popular. The idea of having one generation source create electricity, and this heat that is created right now is lost energy. We need to encapsulate this energy, and we need to harvest it and turn it into heating. So the idea would be, right, let's put in a generation source. That's the thing with that. So you're going to have room for a generation source. Cost of that, space, the ability to capture heat. Is the heating system up for debate with your design? Is the heating system an option? Ground and air source pumps, again, similarly, if it's a ground source, which is much more effective, there's obviously the area. Have you got the ground to dig up to install it? If it's not, and it's going to be an air mounted, going on the side of the building, you may need some planning for that, because they're big things to go on the side of a building. So with micro hydro systems, you got to have a body of water. You can't. You need to have some water to actually turn this system. And you may need planning permission for that. You can't just chuck one in the stream that's public. If it's a public or an authority-owned thing. If you need to consider permissions for that. So there are factors that will determine the suitability of all alternative energy sources. You may be able to use 1, 2, or 3 of them. You may just have one option. You may have none. Okay, but those are the considerations. Those are the things that would be up for debate. And your scenario, your design, may throw some clues as to benefit, and it might then say, which environmental system would be of use. Look back to your design information; it would say there's a lot of something that will suggest an environmental system would be of benefit. With 5.2, not a lot really to go on other than what's here. Modules, inverters, control devices, generators, heat pumps. Do you understand some of the components part of these environmental systems? If you don't, do a bit of revising on that. Obviously a wind turbine, we can get some that mount on the roof. They're not going to achieve a lot of energy, but the ones that do achieve a lot of energy are the ones that, you can see from miles away. So you need to, understand the difference in these systems. 5.3, the factors that contribute to reducing energy consumption in a building. Do remember this is obviously an electrical design. So we're going to say, well, we have to have an effective building management system, energy control systems. It's all about automation, isn't it? That's it, really, from that perspective. Okay. You could add a bit about things like, you can consider. There was mention of this with the potential Part 8, which they've now retracted. You can consider oversizing some cables to help reduce thermal losses, because we design cables to try to make them as small as we can from an economical perspective, but that would mean that some of that energy is lost due to the cables being allowed to heat up towards 70 degree or 90 degree respectively. If we were to say, right, let's put that cable one size bigger, which means it's not going to heat to 70 degree, it's only going to go to 45 degree. Now, we've spent a bit more money for the copper in the first place. That's a big negative, it's a big negative balance there. But then over time, how much heat is lost due to the conductor reaching the optimal temperature? Those are things you could consider, but I'll be honest, you're scraping a little bit with that, because that's where Part 8 kind of was going, and then people decided that was not for designers. But we'll see. There is an IT guidance book on energy efficiency, which I have, and I have no clue where it is amongst all my other books. But it's a green one. You could read that, but you will not be penalised for not having that information. You don't need to be some kind of ace energy efficiency genius for this. It's just more of a awareness, a consideration. Remember, it's just one question, so can't be too hard, can it? Good.